You know that feeling when discussions about aging populations pop up? All the talk about healthcare costs, pensions. It can feel, well, a bit much sometimes.
Yeah, it sounds like this huge looming problem list.
Exactly. Well, today we're hoping to cut through some of that. We're doing a deep dive into an article called Confronting the Global Demographic Time Bomb.
Hmm.
And the idea is to pull out the really critical stuff, the insights that, actually help make sense of it all.
Right. And this article, it's interesting because it doesn't just throw numbers at you. It tries to weave together the stats, the latest biomedical science, and some ideas about what we might actually do about it.
So it's more than just demographics.
Definitely.
Yeah.
Think of it as trying to get to the core arguments, understand the science, and see the bigger picture beyond just the headlines. Our mission really is to unpack that.
Okay, let's get into it then. The article kicks off by setting the scene right with the demographic reality.
Yeah.
What are the headline numbers we need to grasp?
Well, the big one is how the global population aged 65 and over has changed. Over just the last 50 years, it's almost doubled as a percentage.
Doubled. Wow.
Yeah, from about 5.5% back in 1974 to 10.3% this year, 2024.
Okay, that's already significant.
And the projection, by 2074, so another 50 years, it could hit 20.7%, more than 1 in 5 people globally.
1 in 5. That really changes the shape of society, doesn't it? You think of the old population pyramids? This sounds almost like it's flipping.
It's a massive shift. And it's not some distant future thing either, especially in advanced economies. The article points out, I think using OECD data, that by 2022, it was already around 19% there.
19%. So almost at that global 2074 projection already.
Pretty much. And these aren't just numbers, obviously. This translates directly into, real pressures, huge strains on healthcare, obviously.
Yeah, you hear about that all the time.
And pensions, funding those becomes a bigger challenge. Labor markets change. There's even the potential for slower economic growth overall, and maybe some friction between generations over resources.
And the article suggests that the sort of standard answers we hear, like, oh, just increase immigration or focus on curing cancer, they might not be the whole solution here.
That's a really key point it makes. Immigration can help, sure, it brings in younger workers, but it often doesn't fundamentally change the aging trend of the native-born population long term.
Right. It's a temporary patch in some ways.
Kind of. And tackling specific diseases like heart disease or cancer is crucial, obviously. But geroscience argues that doesn't address the underlying reason we become more vulnerable to all those diseases as we age.
Ah, okay. So that's the pivot point, this idea of geroscience. Can you give us the quick intro? What is it exactly?
Geroscience, in essence, is the study of the biology of aging itself. Not just the diseases associated with aging, but the fundamental biological processes that drive it. Why do we age? How does it happen at a cellular and molecular level?
So it's going deeper than just treating symptoms or specific illnesses.
Exactly. And the article highlights 4 areas within geroscience that are looking particularly, promising right now.
Okay, let's break those down. What are they?
First up is senolytics. These are basically compounds or treatments designed to find and clear out senescent cells.
Senescent cells. Those are the ones sometimes called zombie cells, right? They hang around but don't function properly?
That's the ones. They stop dividing but stick around, secreting stuff that causes inflammation and messes with nearby tissues. Clearing them out shows promise in animal models for improving various age-related conditions.
Interesting. Okay, what's the second area?
That's telomere maintenance. Telomeres are these protective caps on the ends of our chromosomes. Think of them like the plastic tips on shoelaces.
Uh-huh.
They tend to get shorter each time a cell divides, and eventually that shortening is linked to cellular aging and breakdown. So researchers are looking at ways to protect them, maybe even lengthen them using enzymes like telomerase.
Protecting the ends of our DNA. Makes sense. What's number 3?
Number 3 is epigenetic reprogramming. This one's a bit more complex. It's not about changing the DNA sequence itself, but about resetting the epigenome, the chemical marks on the DNA that control which genes are switched on or off.
So, like changing how the existing genes are used.
Right.
Bringing them back to a younger pattern of activity.
Exactly. It's like restoring the software settings without changing the hardware. Early research, again, often in mice, suggests it might be possible to reverse some aspects of aging this way.
Fascinating. Okay, and the fourth one?
The fourth is stem cell therapies. Stem cells have this amazing ability to develop into different cell types, so the idea is to use them to repair or replace damaged tissues and organs that decline with age. Regenerative medicine, essentially.
Right, so senolytics, telomeres, epigenetics, stem cells. It sounds quite sci-fi, But the article stresses this is moving forward.
Absolutely. These aren't just theoretical anymore. Research is accelerating, moving towards, potential human applications. And a huge driver of that acceleration is artificial intelligence.
AI, of
Yeah.
course. How is AI fitting into this picture?
It's becoming indispensable, really. AI algorithms can sift through massive amounts of biological data way faster than humans ever could.
So for finding potential drug targets.
Yes, exactly. Identifying molecules that might interact with aging pathways, predicting which compounds might work as senolytics, for example. It's also crucial for identifying new biological targets involved in aging that we didn't even know about.
And modeling, I suppose.
Definitely. Predictive modeling is huge. Using AI to simulate how interventions might affect aging processes or to predict how someone's health might trajectory based on biomarkers. It all speeds up the research cycle dramatically.
And the goal here, connecting back, is extending health span.
Precisely. That's the term the article really emphasizes. It's not just about adding years to life, but adding healthy, functional years, reducing the time people spend suffering from age-related disabilities and diseases.
Makes sense. Quality over just quantity.
That's the idea. But the article is also realistic. It points out some pretty significant hurdles.
Okay, what are the big challenges or nuances we need to consider?
Well, a major one is the translational gap. What works wonders in a petri dish or a mouse doesn't always translate easily, safely, or effectively to humans.
The jump from lab bench to bedside.
Right. It's a long, complex road. You've got huge regulatory hurdles to clear, making sure things are safe. Clinical trials take years, cost a fortune.
And even if something works, there's the question of who gets it, right? Cost and access.
Absolutely. Equity is a massive consideration. Will these therapies only be for the wealthy? How do we ensure fair access? These are big societal questions.
Yeah, definitely. The article also mentioned regional differences, didn't it? How aging isn't playing out the same way everywhere.
That's another critical nuance. The challenges and potential responses look quite different depending on where you are. Western countries might lean more towards immigration or certain policy reforms. But then you look at places like Japan or South Korea in East Asia. They face really acute challenges with super low birth rates, very rapidly aging populations, and specific cultural norms around family responsibility for elder care. The solutions might need to be quite different.
So no one-size-fits-all approach globally.
Not at all. Context matters hugely. And public attitudes matter too. How comfortable are people with the idea of interventions targeting aging itself? There are ethical debates to be had.
Which leads nicely into the policy side. What does the article suggest governments and societies should be doing?
It proposes a few key things. One is this idea of dual-track funding. Keep funding research into specific diseases like we do now.
Right, the traditional approach.
But also significantly ramp up dedicated funding for fundamental geroscience, research targeting the aging process itself.
So betting on both horses, essentially.
Kind of. It also argues for more regulatory flexibility, not cutting corners on safety, but maybe finding smarter, faster pathways to approve truly promising therapies, perhaps like the accelerated approvals we saw for some COVID vaccines.
Okay, makes sense. Anything else on policy?
Yeah, preparing labor markets is key. How do we adapt work, retirement, lifelong learning for potentially longer, healthier lifespans? And crucially, building in safeguards for equity, making sure the benefits are shared widely.
And getting the public involved.
Absolutely. Public engagement, open discussion about the ethics, the implications that's seen as vital. These aren't just scientific issues, they're societal ones.
So if you had to boil down the article's main argument, its core message, what would it be?
I think the central thrust is, look, global aging isn't just some side issue or a purely medical problem. It's a major structural, economic, and social force reshaping our world right now.
It's fundamental.
Yes. But, and this is the hopeful part, we have this emerging toolkit in geroscience, supercharged by AI, that offers a genuinely new path forward, a way to potentially change what aging means.
But it won't happen automatically.
No, it requires deliberate action, political will, serious investment, and that broad societal conversation about what kind of future we want. The ultimate goal, the article argues, needs to shift.
From lifespan.
To health span, viewing longer, healthier lives not just as nice to have, but as a medical goal, an ethical responsibility, and actually a smart economic move too.
Right. So wrapping up this deep dive, we've covered quite a bit. The sheer scale of population aging globally.
Those striking number.
The limits of some of the usual fixes.
Like immigration or just disease by disease research.
And then this really fascinating potential emerging from geroscience. the senolytics, telomeres, epigenetics, stem cells, all accelerated by AI.
Yeah, the science is moving fast.
But also acknowledging the hurdles, the translation gap, cost, equity, regional differences, and the need for smart policy and public buy-in.
It's a complex picture.
Definitely. So thinking about all this, the trends, the science, the societal shifts needed,
Yeah.
here's something to chew on. What do you think might be the biggest surprise, the most unexpected twist, positive or negative, in how we actually adapt to all this over the next, say, 20 or 30 years?
That's a great question. Will it be a scientific breakthrough we can't even imagine yet? Or maybe a completely unforeseen social reaction?
Or maybe the economics just forces changes we aren't anticipating. It really gives you something to think about, doesn't it?
It certainly does. The implications are huge.
Well, thanks for exploring this with us today. It's a topic that touches everyone, and we definitely encourage you to keep thinking about it, keep exploring these ideas and what they might mean for all of us.